Follow-ups on that. Okay. Correct, 16. Here's how to do it. 2 ways to do it. 3 ways to do it. Slice in a rectangle. What's the area of a rectangle? Height 4, length 2. Slice into a triangle. What's the height of that triangle? What's the width of the triangle? Length, base of the triangle? Half base times height is? What's the total area? Good. Second way to do it. What? There. Okay, pardon me. Second way to do it. Slice this. Draw this, cut this out on a piece of paper, cut that line. This area, this little bitty triangle, could go into this space, yes? That fits nicely. What have I got then? I've got a rectangle of height 8, width 2. 8 times 2 is 16. Hey, I don't need triangle formulas anymore. Moreover, 8 is the average of 4 and 12, is it not? Yes. 4 plus 12 over 2 is 8. Yes, yes, yes. So what does 8 represent? The average velocity. Oh my God. If I just find the average velocity and multiply by time, distance equals rate times time, anyone? Now, this isn't a new equation. This isn't a new concept. This is a different way to slice the graph and interpret the meaning. Follow-ups on, no. This is subtle and important. Turn to your neighbor and tell each other, what did Tucker just say and why did he say it? Gesundheit. Inevitably, when you try to explain something you just learned to somebody else, you reveal that your knowledge is maybe imperfect. Ask me a question. What is the average of final and initial? It starts at 12, ends at 4. Average of those is 8. Yeah? Was it you? Who had the other question? Yeah. 0 and 8 would tell you the displacement between times 1 and 3. If I average that would tell me the area of this triangle. Has a meaning, just not what I asked. Yeah. Please. Tell me why.
I guess the area of the displacement.
Well, let me ask you, if I go at a steady 60 miles an hour for 2 hours, how far did I go? Think about it. If I go for 2 hours, 60 miles an hour, how far did I go? 120 miles, right? Okay, 60 miles is the height, 2 hours is the width. And as it turns out, the magic of Isaac Newton discovered something long ago. The magics, is that works even when you don't have straight horizontal lines. Okay. Other questions? Surely there are other questions. I'm sorry, I didn't mean to call you Shirley. That's your name is Shirley. 4. Oh, what's the slope of this line? Do you know, does anyone want me to review to find the slope? Rise over run. I pick any 2 points on this graph. Let's pick 0, 12, and 3, 0. The rise is the change in y. I think the rise is from 12 to 0 is, how far have you risen? Not 12. Negative 12. I've risen if I go that way. If I go that way, it's a negative. Yeah. Okay, so delta y is negative 12. What's run? 3. 12 over 3. Negative 12 over 3. Negative 4. So negative 4. The meaning of him is the slope of this line. Why is that important? That turns out to be acceleration. Okay. I think we've juiced this for the learning in it. Let me give you a couple of equations. This is what we just did. I'm just writing them out. If velocity is changing steadily, note this is not always the way that velocity changes. You can have something which does not change with uniform constant acceleration. It's just I'm not going to give you stuff like that on your quizzes, homeworks, tests. You could just find an average velocity by looking at what was the velocity at the beginning, what was the velocity at the end, average it. When you do that, for that time interval between that initial time and that final time, you could just find displacement equals VT. As simple as that. And where does this come from? Well, you can find that geometrically. What I told you before and what I'm telling you now, this isn't a different thing. It's just a different way to look at the same thing. So displacement is half V initial plus V final times time. Please note these be vectors, meaning if one of the velocities is negative, you might end up with 0 displacement or negative displacement. These quantities can be signed. As I said again, this is not actually a universally true equation. The average of changing slope is not just initial plus final over 2, but it works for what I'm going to give you. Yeah.
Does it translate to?
Linear. Okay, so here's an equation. You may use this on the homeworks, on the tests. I strongly encourage you, don't memorize them. Don't write them down on your equation sheet. Understand him. Understand him, make him a part of you. Chew on this idea. Average velocity times time. Well, of course, velocity times time is displacement. Questions? I'm going too fast, aren't I? Yeah. Doesn't work. You would have to do the integral calculus, which is beyond this course. If anyone wants to see the calculus of physics, ask me after class. But not for too long because I've got a 1-year-old. It's really my default explanation for why I do half of the things that I do. Sorry, 1-year-old, gotta go home.
Why is X a vector?
Because the change in position can be left, change in position can be right. It makes a difference. Use displacement, not just distance. Distance equals average speed times time. Displacement equals average velocity times time. Good question. Okay. If nobody else has questions, we shall move on. I already said this. Acceleration is the rate at which velocity changes. That means it's the slope of a V graph. V is the slope of X. A is the slope of V. Distinguish carefully between these. If you get them confuzzled, you cannot possibly get the question right. You're working on something. A is the slope of V. V is the slope of X. That's what a rate of change means. It's the slope of that quantity with respect to something like that. Gesundheit. Okay, so average acceleration is rise over run. What's the rise on a V graph? Delta V. What's the run on a V graph? Delta T. Delta V over delta T is average acceleration. And as I told you, I'm not going to give you changing accelerations, except for maybe in a qualitative problem where I ask you, is this slope getting steeper or shallower? What does that mean about the acceleration? I will never ask you to evaluate, find with an equation an instantaneous acceleration. So again, for most of this course, you could just say the slope of the velocity graph is constant. That's the acceleration. Okay, I've been talking too long. F, F, F. You can talk to your neighbor. Sorry? Did I not? E was what's the area of what's-the. But if you get like more than half of the questions, I give you full credit for that. Sure. F, Ryan B, F. Oh, that's the sweetest thing ever. Okay, give me your best guess. Three. Velocity tells you which way you're moving. Positive velocity, upward motion. If you've got a positive velocity, but acceleration is negative, acceleration is pushing against that positive, decreasing his value. Decreasing an upward, decreasing a positive is a downward slope, negative acceleration. Which of these goes up and slows down? Good. Next one. G. O, G. I didn't do it.
Yes. Is moving up always positive?
Yeah. Okay. Up is positive, right is positive, unless I specifically tell you otherwise. Also north and east. What? Coordinates for position. I mean, I would say up is positive, defines any coordinate, any location coordinate. Ooh, we got disagreements now. I didn't do it. Yes, sorry.
going against each other. I didn't write that down.
If you got a positive velocity and it's decreasing, your acceleration is negative. You're pushing towards zero. If the slope is opposite the value, the sign of the value, that's slowing. You slow if the positive values with the negative slope or negative values with the positive slope. I mean, think about it. That's how you trend towards zero. Acceleration positive or negative means the slope of velocity is positive or negative. Acceleration does not mean speeding up. That was one of the things I told you to write down. Positive acceleration. Okay, well, you should have written it down. Acceleration does not mean speeding up. Negative acceleration does not mean slowing down.
I just.
Good. Now, question. Okay, take your best guess. Wow. Lots of people struggled here. This is William Riker. Number one. Number one. Why? The direction, actually, most people got the direction right. Descending or dropping downward shows you the direction of velocity is negative. Negative acceleration and negative velocity means your slope is negative. If you're already in the negative numbers and your slope is negative, is that taking you closer or further from the horizontal axis? You're in the negatives and you're going downer. What a downer. You're going further away from the horizontal axis. You're getting negative or you're getting faster. Which of these speeds up? Listen. For what it's worth, if you're going in a straight line at a constant speed, the answer is always acceleration is zero. You can actually write that down. You'll screw up on this at least once. Everyone will miss at least one time. When we talk about Newton's first law, the punchline is, if your velocity is constant, your acceleration is zero. I mean, think about it, right? What's the slope of a steady line at zero? If you've got a steady slope, you can't be changing. I want to emphasize something that I said before. Negative acceleration does not mean slowing down. Positive acceleration does not mean speeding up. Slowing down if velocity and acceleration are opposing. Speeding up if velocity and acceleration are aiding. Positive velocities that get positiver, negative velocities that get negativer, those take you further away from zero velocity. That's a speedy uppie. Positive, positive, speedy uppie. Negative, negative, speedy uppie. Positive, negative, negative, positive, approaching the horizontal axis, that's slowy downy. So if one is positive and the other is negative, doesn't matter which is which, that's a slowing. Again, one last time, because it's such an easy mistake to make, deceleration, slowing down, is not negative acceleration, necessarily. Okay, we've done a bunch. I'm going to gift you some equations. I would like to derive these. Experience has taught me, though, that showing where these come from at this point in the semester, at this point in the afternoon, is, well, let me just say that if you want to know why, I will very happily office hour or Zoom it. It's actually kind of fun. It's just a little algebra, but right now algebra is only for algebros. Yeah, if you're an algebro, come see me. And bro is gender neutral for how I mean it. Actually, why isn't bro masculine and bra feminine? Anyway, moving on. Displacement equals initial velocity times time plus half acceleration times squared. Final velocity squared, I'm just reading out what the equations say. Final velocity squared equals initial velocity squared plus, that's a 2, not a z. acceleration times displacement. Yeah? Now let's apply these. What did we do before? We found that the displacement in that one time interval was it 16 meters? Oh, for dog's sake. I think I did from 0 to 2. Let's apply these equations. Delta x equals, what's the first equation say? Initial v times time plus time squared. Okay, what's the initial in this case? At 0 seconds. What's the time interval that I've picked? 2, it's 2 seconds on the horizontal, right? What's the acceleration? -4, goodly. What's the time again? Oh, 2 squared. Okay, let's, arithmetic here, 12 times 2 is, if you grabbed your calculator, no, 12 times 2 is 24, good. What's 2 squared? Times 4? Divided by 2? Good. There's a minus sign. 24 minus 8 is, ta-da! Equations work. I didn't lie to you. Dun dun dun. Or, what's the other equation? V final squared equals V initial squared plus 2a displacement. If I want displacement, plug in everything else. What's final velocity? What's initial velocity? Only two people answer that. Did you get lost about why it's 4 and 12? No one said yes, so I'm going to assume you all know why it's 12 to 4. What's the acceleration? Oh, okay, I'll tell you. I am looking at a time interval here. I have to define the time interval or you can't solve these problems. Initial and final refers to some time interval. You got to specify that. So here's my initial value. Here's my final value. What is V at the beginning of time? What is V at the end of time? E12, E4. Yeah. What's A? Okay, what's 4 squared? It's a website. Just kidding, that's 4 square. What's 12 squared? 2 times -4. Okay, how do I solve this algebra? Can someone walk me through the algebra here? Can some algebro or bra help me? What do I do first? Honestly, I like to get the x positive. What can I do to get the x positive? I throw 8 delta x over to the other side. I like to write 8 delta x plus 16 equals 144. Supposed to be. Okay, then what do I do to get x alone in a dark alley so I can beat him up and take his change? Sorry, what do I do to get x alone in the equation? Subtract 16, what do I get? What do I do to get x alone now? Which you will be shocked to hear is delta x is 16 meters. Yes? Question. Huh? These are vectors. They can be negative or positive. Hey, we plugged in A as negative. Did I forget the vector signs on top? I'm sorry. These should have vector signs because they could be positive or negative. Questions? We're almost done. Almost done. Give me a question. Come on. Something in here isn't making sense. This is hard. What's a vector? A vector is something, in this case, in one dimension, plus or minus sign. Up or down, left or right, in or out. Oh, those are directions associated, which we're going to call positive and negative. Opposite is a scalar, something that only has a magnitude. Other questions? Ask me about farming. Other questions.
Sure, what does delta X represent here?
Displacement, change in position. How far have I gone? 16 meters. One more question, and I shall be satisfied. I am a question vampire. Give me a question.
This one, with rather than the delta X equals 1/2 the initial velocity per time initial velocity per time.
Style. I mean, how do you know what equation to use? How do you know what method to use? That's the student's choice. All of them give you correct answer. If you apply them correctly, pick one and do it. Having some flexibility helps though. If you forget one way to do it and you can figure it out based on another way to do it, that's important. Yeah.
Question.
Oh, good. My question vampire sense was not tingling, but here we go. If I asked for total displacement, would I add the 20? No. If I were asked for total position, I would add 20. Total displacement is 16. Displacement is the change in position. If I change by 16, and I start at 20, 36 tells me where I am, not how far I've gone. Again, position, where are you? Displacement, how far and which way have you gone? Write that down. It'll be on the test, probably. Meaning, displacement tells you how far and which way did you go. Position just tells you where you are. Displacement tells you how far and which way you've gone, positive or negative direction. What the H? Here, answer this. This is H. If enough people get this right, I'll let you go. 100%. No, not quite. You may use your notes, by the way, especially the notes where you wrote down things that I told you multiple times. Hint, hint. Question.
Does that mean like flat line, or does that mean
Slope is 0. At some time, you are not moving. At some instant, your instantaneous velocity is 0. The slope of your velocity at that instant is 0. Okay, everyone to vote. Don't be like my generation that doesn't vote. Hey, by the way, I can't ethically give you extra credit for registering to vote, but I can give you brownie points. Please, 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 please register to vote and participate in democracy. We might not have it for much longer. It's important. Cough, cough. So the correct answer is true. If you got this wrong, write in big bold letters. You can accelerate when you're not moving. How? If your velocity is 0 at an instant, that doesn't tell you what your slope is. Look, here, sketchy, sketchy. Here's a VT graph. My velocity at time 4 is 0. What's my slope? I don't know. We don't know. Value doesn't tell you slope. You have to know how it's changing. There. There, here's my velocity graph. Am I accelerating? Am I moving? No. Here's my velocity time graph, VT graph. Am I moving? At this instant, I'm not. Am I accelerating? You betcha. Positive or negative? Okay. I want to give you guys your money's worth. Oh, let's say this. If you've got further questions and the mental and emotional energy to take the full class period, I will teach. If you're done and you got the last question right, get out of here. Please remember, Slava Ukraini, I love each and every one of you. You are all fantastic people. Go fast, though, because I do want to teach the 5 people who stay. Sure, I'll do your homework. I mean, hint. Sure. Yes. That's a good one. Can you tell me what the velocity graph looked like again? What did he start at? Yeah, just draw it. Draw it for me. Thanks. You just put it up. Yeah, if you're willing. You're good. You're good. You're grown up, and I will treat you as such. You're grown up, and I will treat you as such. I assume that you have good reasons for doing.
I find it disrespectful, so I just wanted to let you know.
If you're snoring in class, then my feelings are hurt. You're fine. You're fine. Good questions today. Keep it up. Good.
I need to learn.
Yes.
I haven't taken physics since I was about outlook and
Trousers. Oh my God. Is it really 20 people staying? Ah. Well, that makes me feel all happy.
Gonna do like changing acceleration.
Yeah. Well, we can have piecewise constant acceleration. 1 meter per second squared, then negative 1 meter per second squared.
How would deceleration look like? Acceleration versus time. I'm just
You
curious.
can't tell if you're accelerating or decelerating based on
If
AT graph.
acceleration numbers are approaching 0, wouldn't that?
The value, the magnitude, is it positive or negative does not tell you speeding up, slowing down. You have to know the sign of acceleration and of velocity. How acceleration changes doesn't tell you which direction the velocity is.
I kind of get it.
Office hours. Ask me again. Yeah.
For some reason, it's not really letting me create a new account. I think I have to like for.
Yes. Okay. Crap. Can you stick around and I'll show you how to do it after? Do you have time? Will you Zoom me and I will walk you through it on Zoom?
Sure.
Okay. It's in Canvas. You go to the Brightwave tab, copy a code and put it in somewhere.
Try to pop it up there and see if it will work. Just last question. So the ones that I send you on email, I am very sorry. They're not perfect.
No, no one's perfect. Chillax
Like
about
I
that.
did not do all of them because I was confused, but
Okay.
when I came today, my classmates told me that it's actually open. I'm sorry for falling behind. Like
What's open? What?
the mastering in physics.
Chapter 2 is. Homework 2 is. Homework
So-
1 isn't open. No, you did homework 1. That's what you should have done. Now do homework 2. Oh, I need to post that for people who are still off mastering. Will you email me, all caps, hey Tucker, post 2.
Oh,
Because you should have time to do that. Sure.
Hi, for the pre-lab, for my lab,
That's it. Yeah.
this right here.
Well, that's the file you need to download when you're in there. That's the activity itself.
Oh,
That's
so this
the
is
document.
so
Oh, no, the pre-lab.
the
You said
pre-lab.
pre-lab,
Yeah,
sorry.
yeah, pre-lab.
I goofed. I did not write a pre-lab this week.
Oh, so there's no pre-lab in it?
Future weeks there will be.
Yeah, yeah.
Not this time.
Yeah, because I saw there was one for 3, but not one for 2.
Yeah, no, I goofed.
Yeah.
I'm so
Have a
goofy.
great day.
Upward motion, slowing down, that's 3. Going up, slowing down, that's 3.
but it doesn't include the fallback.
No, before it starts to fall back down.
So, you said, just want to remember this, but so you said we have a midterm and a final, right?
Two midterms and a final.
Two
It's on the
midterms?
canvas. It's on the syllabus.
Two
Yeah, look at
midterms.
syllabus. I'll post lots of people are asking when is the midterm. I mean, it's on the syllabus, but I'll put the dates in Canvas.
The graph, I just have this last question.
Sure.
For the graphs, the location doesn't really matter as much as like where the graph is going, right?
Oh, they both matter.
I mean, yeah, but
They
like,
tell you different things though.
so
Is
like,
position increasing? That's positive velocity. Is position negative? That's left of an origin. That's different factors about it.
because on the exercise that we were having, it was going to the negative direction.
What?
but it was
Velocity or
accelerating.
position?
Position was negative, but the velocity was going like accelerating, like going faster.
Okay,
Yeah, so that's why I was like, I was a little bit confused, but then,
but it tells you two different things.
yeah. Yeah.
Zoom me. We'll do a session and all shall be clear.
So I can see-
No, I will make time for you. You tell me when you're available and I'll make time for it.
It's like.
Do we have to schedule?
No. Oh, yes. I used to buy them, but it was like, I was spending $200 a semester. I used to teach small classes. I also used to buy people pizza for the final. I can't do that with 200 students.
Good.
This close to taking physics in like downtown or something, but my sister had her class.
Aw. Instead of warning you away, your sister really did you a bad one.
She did.
Aw, thanks.
And then also we don't get cheat sheets on these.
3x5. Index card. No, you can get to make it, but
Okay,
it's a 3x5, not a whole page.
thank you.
Sure.
This is not exactly the scale.
All right. Here's a problem. Oh, this is not the one I thought you were saying. Okay, this does not actually show what you just sketched on. This vertical axis is X, not V.
That was
Okay, so this is question,
the last.
this is question,
Yeah.
question 1, number 20. Who else struggled with this one? Yeah, I give you a position time graph and ask for velocity. Yeah. She should have emailed me or texted me. If she doesn't know, huh? She's got my contact information. Next time she struggles, tell her to email me. What?
I just have.
Cover over it, it tells you like a valve. or
Tells you
something.
values. But the values aren't the velocity.
Yeah.
The way to find velocity, what's velocity on a position graph? Someone tell me? Slope. So let's construct a line that is tangent at the point 4. Look, that barely grazes the point. It has the same slope at time t equals 4. Sketch this on and then look, I think this goes from maybe 2, 0 to 6, that actually worked out quite nicely. I think that goes from 2, 0 to 6, 400. 400 over a rise of 4, I think 10-ish.
For which one?
This quiz is number 1 homework.
Homework one, the last question.
So you have to take the 2 points that take the subtract the top, and then the bottom. It gives you 2 points you hover over the graph.
It gives you 2
Yeah,
points
it
that
gives
the
you-
x goes through.
3 seconds, 0.5 seconds, gives you the x, it gives you the y value.
Oh, so you can do a rise over run very close to that. Okay, that too. Okay, so if you zoom in and look, it does give you those points, then you can do rise over run for those as well. Otherwise, I just zoom in and sketch. What's the rise? How much does that line go up? Yeah, what's the run?
2, 4, yeah. Okay, but then.
What the hell?
30?
What the hell? What the hell?
See, that's why it was confusing, because I did the whole I did like a later distance minus of earlier one and then divided it by it, and it got I think I had 75-ish or something, and I was like, no, it's 70. And I was like, okay. And I did it for this one, and I couldn't get the answer on that one. I just got it wrong.
Oh, no, no, oh, crap. Will you email me about this and I'll take another look? Or that. Okay, so, velocity graphs. Interpreting velocity graphs was the #1 question in both sections. I think, although I will take your requests, I think a useful thing to do might be to summarize, condense, review, revisit the general properties of these. I have been doing my darndest to make this not a memorizing list of properties. That's chemistry, man. But a reasoning through why. The disadvantage of reasoning through why a lot is there's a lot. There's a lot of stuff, right? There's a lot of stuff, and sometimes you can miss the forest for the trees. So let's review briefly. Let's review properties of VT and XT graphs. I still don't know what I was goofing on there, by the way. Come on, next slide. Next slide, next slide. Next slide, punk. What the hell? Okay, this is just going away. I'm doing something stupid here. That's what she said. I don't know, ask your mom. Okay, anyway. Okay, so as I was saying, wow, that really works, didn't it? Oh crap, the recording's on. As I was saying, properties of XT and VT graphs. XT. What can we conclude about being near the horizontal axis? What do you know? From, no, XT graph. If you're near x = 0, you are close to an origin. Near the horizontal axis means where you are. Remember, position tells you where. Velocity tells you which way and how fast. What does it mean if x values are far away from horizontal? You're far from the origin. What does it mean if you have positive x values? Let's be concrete here. Let's be concrete. Let's talk about up-down is our coordinate system. This table, the surface of this table, this is x = 0, x = 1 meter, x = 2 meters, so on. Okay, so what does positive x mean in this example? Above the table surface. What does negative x mean? Good. What does it mean to have a positive slope? Decreasing, increasing what? You're moving upward. You're not necessarily going away from the origin. This is increasing position. Yeah. Okay. Note, the motion sensors in class can't look behind themselves, so sometimes they give a misleading impression because you never see negative positions. Okay, so positive slope tells you're moving, in this case, upward. What does a negative slope tell you? What does it mean to have no slope, 0 slope? I would describe that as at rest. Okay. What does it mean to have a changing slope, to have a curvature? Acceleration. What happens if the curvature is getting more intense, steeperifying? I would say speeding up. It's always acceleration. You know, to a physicist, a steering wheel, a gas pedal, and a brake are all accelerators. They all change velocity. Steepening position time graphs show speeding up. Happy smile, sad smile, positive, negative. Look at how the slope is changing. The slope is going from negative to negative steep to positive steep. That is an increase in slope. What is the slope doing? Negative slope at all means moving in the negative direction. Steep slope means fast. So this is slowing down, this is speeding up. It's all positive concave. That's all positive acceleration. Again, let me bang on this a little more. Bang, bang, bang. Positive acceleration does not mean speeding up always. First I slowed, then I sped. Does that answer your questions? Goodly. I think I've got one more. What does a slope which goes away from horizontal axis tell you? You are getting farther from the origin. What is a slope that points towards the horizontal axis tell you? Approaching the origin, yeah. Does a slope approaching mean velocity is always negative? No, you can have a positive velocity which is approaching the origin. Please note, like I was saying a minute ago, in the lab equipment can't show negative positions. Is everyone in the lab? The lab equipment can't show negative positions, so you may get the misleading impression that negative slope always means towards. That's not true. Slope towards horizontal axis means towards. This is a negative slope that takes you further from horizontal. Yeah. If you start at the sensor, how can you go towards it? Oh, which direction you face is completely not in physics. Tell me about where your center of mass goes. You are standing at some position that's not the sensor. Sure. Are you on the positive side or the negative side of the sensor? Wait, are we talking specifically about the lab gear? If you're standing behind the sensor, it can't see you at all. That's what I'm warning you about. So you have to stand in front of the sensor. If you have motion like that, you're moving towards the sensor. If you have motion like that, the sensor can't read you. You'll never see that. But that doesn't mean that that kind of motion doesn't exist. It means that these lab sensors don't know negatives. Stay positive. Anyway. V-graphs. What's true about all these points? A line that is horizontal there. Not moving. What does it mean about anywhere in this region, any velocities that are close to zero? What can you say about them? Not necessarily slowing down. Just that's slow motion. If velocity numbers are close to zero. If velocity numbers are far from zero, what can you say? That's fast. Points out here represent fast motions. Why? Because v is far from zero. Speed is absolute value of v. If I go from here away, what am I doing? Speeding up. Why? Because I'm going from slow to fast. If I go from fast to slow, oh, if I have positive values, negative slope, if I have negative values, positive slope, what am I doing? If I have a positive slope, am I speeding up? No. Watch out for it, trick question. If I have a positive slope, I could be speeding up, I could be temporarily at rest, I could be slowing down. If I have a negative slope, wow, I'm gonna break my arm. If I have a negative slope, I could be moving upward, coming to a peak, and then turning back around. What do positive velocity numbers tell you? Moving upward. Negative velocity numbers? Downward. What does the slope of velocity tell you? Measuring the slope of velocity. Acceleration. What if the slope of velocity changes? What's that? That's a trick. It's jerk. It's outside the scope of this class. It's something I won't give you. You're welcome. I do want you to know what we don't cover. I did not understand it, but I want you to know that there are things that physics explains that we won't talk about. Yeah, question.
Graph will always on a XT graph represent a curve. An XT graph is a curve.
XT curve corresponds to VT slope. You betcha. Oh, oops. What's area on VT? What's area on XT? Oh, we haven't discussed it. It's nothing. What is area on AT? Take a guess. step. Change in velocity, yeah. Anytime you've got a rate, area of that rate is the change in the quantity. That is a fundamental theorem in calculus, incidentally. I just told you, in fact, it is called, very imaginative naming, the fundamental theorem of calculus. The area under a rate is the change in the quantity. Which in calculus language, they say integral of a derivative is, well, anyway. Okay, general questions.
Now, if that were
Yes.
not zero,
Is the velocity changing? Yes, it is. The velocity is passing through zero, but he's not stopping there. He's not resting there. I mean, meh. I mean, you better say yes. She's mine. She's mine. She's warm. Oh, thank you. Tell me, hold a stopwatch and tell me how many seconds she levitates at the top. Nope. She's always in motion except for one instant and then turns around. There is no time interval that she is completely stationary. Slope is never zero.
so what about with calculus?
Well, stay after class, after the after class session apparently, and say that. The derivative of a linear is constant. Okay, we are past time. Just remember, I love each and every one of you. And it's not actually even that much of a lie. I care about you guys. You're good people.